Hi and welcome to yet another episode of Adventures in .NET. I'm Christian Wenz and have my co-panelist Adam Furmanek today.
Hello, everyone.
And we have a very special guest. Actually, he lives 5 miles from me, but we rarely meet in person. We just recently met actually, but apart from it's super rare. But happy to see him, at least on the screen. Please welcome Florian Rappl.
Hello, welcome everyone.
Hi, Florian. Thank you so much for joining us. You are very active in the .NET space. We run into each other at various conferences and events. And you're also an avid open source developer. And since we all love open source, how about we start with what you're currently been working on with your myriad of projects?
That's right. So I'm always essentially busy, and of course, could be even busier, but the day just has 24 hours and need a little bit of sleep as well, like everyone does. These days, I'm mostly working, well, let's say, on a couple of projects. On the one hand, of course, we have a project many .NET developers know called Electron.net. So this is a joint project with Gregor Biswanger, and essentially a .NET wrapper around the Electron project.
And Robert Music is also contributing, right?
Yeah, so originally he was. He faded a little bit out over the years, of course. So, and at the moment, let's say as active contributors or maintainers, more or less, right? So because community around it is huge, is just at the moment Gregor and me. But yeah, you're totally right. The project was originally started by Gregor and Robert Music. That is totally correct. Right, then the other thing I wanted to mention is AngleSharp, which is a project for C#.NET using or leveraging the space of the web, right? So you can make web scrapers with it, or build other funny stuff. So essentially, it's like a headless browser. And there are plenty of side projects from evaluating CSS to enhance the I/O capabilities, etc. So this is a quite fun project. And the other thing I'm doing recently is a micro front-end framework called Pyra, and it also brings Blazor to micro frontends.
That's quite an exhaustive list, if I may say. Would you like to tell us how you ended up in .NET, right? So what brought you there, and of course what made you create so many projects, so many people are using, right?
Yeah, I mean the last part is rather coincidental, right? So a little bit of, I don't know, luck and passion combined.
I would say that as well. It may or may not be true.
But yeah, so I mean my journey already. So I might be already one of the older .NET developers. So in terms of years on .NET, right? I started not right away when 1.0 was released, but with 1.1 I was on board essentially. So that was right. A little bit past the year 2000, and then with 2.0 I essentially just used .NET on, and then it was just a little bit of a hop over to web development, which was my original drug into software development. So I originally started with the first web pages in the mid 90s, and I tried to explore these words, and of course HTML, and then of course how can you make something dynamic work. So I went into CGI with Perl, and when I had my first guest book, the world was at my feet. And
so were you also struggling like myself that kind of worked locally, but when you were uploading it with FTP, the
FTP,
tool that was given us from the deities above, then the line endings were kind of changed and everything stopped working. Did you have that as well, or was just I
Yes.
so incapable of? Okay.
I mean, my first hurdle was actually to get it. I mean, HTML pages, sure, that was there. But then, of course, once I went into dynamic pages with Perl scripts, my next problem was how to find a provider that actually allowed me to run Perl scripts. So back then, we had GeoCities, for instance, which provided me a free web space, which was awesome, but they couldn't run Perl scripts. Then later, I found some other useful pages that even for low money at all, but then a little bit of an advertisement banner or so, you could run it. And that was quite cool for the time being. And as said, and then later on ended up in .NET. And I think it must be around the year 2005 or 6-ish. There I went then fully into ASP.NET.
I mean, in 2005, I think ASP.NET 2.0 came out, right? So the
yes,
first
yes.
version that could be really used because it worked cross-browser, essentially.
It worked,
well.
but I mean, once, I mean, I was never, let's say, fully happy with that. And I actually thought, I mean, I developed my first version of my blog back then, or a website, personal website, using that technology, but essentially writing my own framework on top of it, because I could never guess what's happening underneath. And of course, it was a horrible framework, and let's not talk about it. But for my personal, of course, usage experience already better. But once they shipped an MVC, right? So ASP.NET MVC. So there, so that's it. Now I'm using this, and then I was finally in love also with the web perspective of .NET, because I thought that was always, I mean, it was powerful, but it was just never felt right to me, right? So especially coming with a web background, and you wanted to have, let's say, all the bits in your hands and know exactly what comes in, what goes out, and there was just a lot of magic going on, and that is what I didn't like so much. And debugging that was quite painful, to say the least. Also, it was always behind, let's say, for instance, Ajax, right? So that was a big trend starting, I think, in 2005, 2006-ish. But it was pretty much impossible to use out of the box in the beginning. And then they added some extensions on top, but there was a lot of magic going on in ASP.NET. But MVC then, for instance, made that really transparent and easy to use. And I was really happy with that. Actually, my blog today, if you go to that site, I mean, don't go there maybe. The design is now 13 years old, but what I can tell you is the technology underneath is also 13 years old. So it still uses this thing, and it is, in my opinion, quite fast. I could understand the code, and I could still extend it, even though it is, I think it's MVC 3 based now. But anyway, so it's, or maybe even 4 already, but only because I had to update. But anyway, so the long story short, that's where I fell totally in love with how they handle the web. And I think that is a good story ever since.
Oh, absolutely. I mean, I also started early. I can just talk about myself, right? I also started early, even back in active server pages time, right?
Yeah.
But yeah, it was a challenge for a while. But then, some meaningful innovations appeared, and this kind of made the platform just much more appealing and gaining a lot of traction. Right?
Yeah, totally.
Right.
Totally.
And then eventually you said, okay, you had to write your own framework on top of ASP.NET Web Forms anyway. How about not write some other few cool things that were not part of the distribution?
I mean, the backstory of AngleSharp, which was, let's say, or is potentially the project with the largest impact in the .NET community. I mean, it has, I don't know, almost 5,000 stars, which in the .NET community is quite large, right? And it is used by, I don't know, 40,000 projects or something like that on GitHub, some massive number. And so I think it's quite good. When I started with it, of course, I didn't start it with this will be big. I just had like often when such projects start, a problem case in front of my mind. I was sitting on a plane actually, and going to the MVP summit in Redmond. And I had this feeling that what was missing, and I think that was 2012 or 13, so it's already like 10 years ago. I was thinking that what is missing is a framework, and now you will laugh a little bit because it connects, I guess, all the things together, a little bit like Blazor. A framework that allows you to use HTML and CSS for making your presentation, right? But then for the logic underneath using C#. So anyways, and I just iterated that through my mind, and I was like, what's missing? I mean, what can I do right now, and what is preventing me to do that? And I ended up with what is missing is actually, I mean, all the HTML and CSS part essentially, because of course C# we know we can make libraries and all that, and I mean already all the presentation frameworks that were there, I mean starting even with Windows Forms, you could customize that they do whatever underneath, and they had already I wouldn't call it perfect component model, but apparently something that worked, right? So people were quite happy with that. So the only thing missing was something then on top, and I figured out quite fastly, if it is really HTML. It can't be just some, something you call HTML, but it's actually just XML and very strict, or something where you say, well, it can just use a regular expression or use the XML parser that's already there. No, it must be something that really works like in the browser, right? So from the parsing perspective. And so I ended up with saying, let's see what's out there. We have, of course, already back then, HTML agility pack, but that's not an HTML5 valid parser. And I could already just, not even now looking up some websites. So just crafting my mind around what were the real innovations behind HTML5. And of course, we got semantic elements and all that stuff. But what we really got was consistent error handling in all the browsers, right? The spec exploded, and it just exploded because all the error handling was suddenly there, and was really everything that can happen is now fully specified. And so there was no way that a browser could behave different from another browser if the browsers are all HTML5 compliant, right? Anyway, so I thought, well, what's missing is a valid HTML5 parser. I need that because then I can understand the HTML and I can make them the right choices, and then maybe I can connect it to C#. And then fast forward a couple of years, and I'm still sitting on the HTML part, because that on the one hand has proven to be, well, I mean, writing something that kind of works, that went fast, but you know how they say, it starts easy, but then it suddenly gets a struggle, and there are all these edge cases, and HTML is, of course, still a living spec, and things get added. And on the other hand,
easy to learn, hard to master. Would you agree?
Yeah, I would agree. And I mean, as you know, I'm also, let's say, reviewing a lot of candidates for job positions and all that. Yeah. And quite often you read always in the CVs, expert HTML. And yes. I think a couple of times I tried then what's that? How will it behave in that? What does this mean? Is this valid HTML, and so on? And I can tell you, I mean, there will be different people out there as well, but all the trials I had, they always failed through the tests. And it's easy with HTML because it always looks so easy, but actually if you really dig into it, you will see there are so many edge cases and things to know, that if you didn't really study the spec, there's no chance that you know all these things, right? So writing some HTML that works, that's easy, but understanding all the HTML that's out there, making the right things, working like the parser in your mind, that's a different level then, right? And therefore, I mean, I still don't want to say these people didn't know HTML. All I want to say is having expert status, it is difficult in HTML, right?
So what was the most surprising for you when reading HTML spec?
There were many areas in there you never heard beforehand, especially in the areas of tables. Table algorithms can be really tricky, how things are handled there. Specific algorithms like the Heisenberg algorithm that they have in there, it has a couple of names, but the one I always like is the Heisenberg. They also have algorithms for how certain elements are then duplicated and so on, especially around what we could consider these days legacy elements. But all in all, I mean, sometimes it was just introduced to mimic certain parsing behavior of browsers like really old Internet Explorers, for instance, but also really old Netscapes are in there. I think all the frame handling was originally all taken from Netscape. I'm not sure. But anyway, so all these, let's say, areas where you say, when is it really applied? Does it make sense? And then you see some examples, and okay, it could happen that we are running into scenarios like this. But I think for practical use, what is the surprising part, how little HTML you can write to have a fully specified document. And I mean, with fully specified, even, with paragraphs in there and whatnot. So that what elements you can drop, right? You don't need HTML, you don't need a head, you don't need all these things, right? They will be auto-inserted for you, and that's fully legit, for instance, right? Also, if you give them a certain order, the browser will always ensure that certain tags will always go into the right areas, that certain things they are magically in the head tag, for instance, and things like that. So it's really tricky what the browser does when it parses and sees your HTML. And maybe also the other thing that I want to highlight in the surprising area is when you compare it, I mean, that you can really see also from an historic perspective where HTML came from, right? Because today you would potentially, if you would start again, it would maybe more look like JSX. Many people think that JSX, so the XML extension to JavaScript, is HTML, which of course isn't true at all. But there you can see this different philosophy working when you go for the new line handling and all that, right? Because there you can just make new lines and intend your code, right? Because it was really meant to be written for the parser. Whereas HTML, if you structure it that you can read it nicely, then you have all these bytes in there that of course are transferred on the one hand side, but on the other side, you can't just minify it and remove all these new lines and the spaces, because potentially it has a rendering effect. All these are collapsed and they are still, depending of course on how the CSS for it is written, will result in a full space being shown in the browser, right? And this is quite often what people don't understand. I just have this HTML, this simple thing, and I copy it over to JSX, and it will render differently. Hello and world, for instance, if they're two words and you have it in 2 lines, so we'll have a space in HTML, but in JSX it's just one thing together, and that's because, right, it's different model behind. And again, I think today it would be maybe structured more that this thing is actually written for machines and not already, right? So it's source code essentially. But back then they said, well, we want to render it out fast, right? And this is the thing. And if it has a space, so we collapse it still to one space. But if it has new lines and tabs and so on, it's just a space. And it's just a different philosophy. Yeah.
One question that I often wonder about is like whenever, like if you try implementing a parser for whatever, let's take HTML obviously in your case, do you think does one really need to read the spec before starting the work on writing a parser? Or can you do that iteratively? Like I do some parsing, I read some more spec, I extend the parser. Does it work this way? Or is it really better to, have the spec written, understood already before working?
Yeah, I think in general, it would be better to have the spec at least, I wouldn't say fully read, but have an understanding on a high level. Otherwise, I would say it depends on the spec. Like what I did and I mean, I wrote over the years, I'm also writing programming languages and so on, where they also need a parser, but then it's a little bit different. So what I did for AngleSharp is I followed the spec really closely. Meaning that if there's a section in the spec, I have a function for it, right? And you could, of course, do, and that's what browsers or real browser engines do. They optimize, of course, a lot of things. And that's, of course, necessary. They want to get the most performance out, which means they also will potentially apply some tricks to the algorithms outlined, which are then implementation details and not, relevant for the whole algorithm, as long as, of course, the outcome stays the same. Now, I didn't do that. I didn't do pretty much any of it. I always tried to stick any line in the spec that says you should do this. I did that. And for me, that was on the one hand side, because the spec was really written nicely, in my opinion. So it's a good spec. If you compare that to CSS, for instance, I mean, CSS has no real spec. The last one was the 2.1, and since then people talk about CSS3, but there is no CSS3, right? It's just now, since CSS3, I mean, that just means it's scattered now. We have all these different CSS modules, and they are all in different levels.
And
exactly, a contour module, etc. So it's a huge zoo out there. And if you want to go for rendering, good luck. With CSS 2.1, you had a rendering spec, but yeah, it's still very hard to read what you should do there, and it's very experimental what you need to do. Still, of course, browsers figured out there the ACID tests and so on, so you can do that. But right now, I mean, you would use this as a basis plus all the other things. You have your grid spec, you have the flexbox one. You now need to have all these things and then decide what rendering mode you're going into. It is very cumbersome. And don't get me started on parsing CSS, which is, again, there is not one spec, because, well, selectors parsing is one thing, but then you are into the declaration spec, and there each value might have a completely different shape. So you need a sub-parser essentially for everything. You, of course, have little grammars in there, like for colors, etc. But then everything is different. It's a huge zoo. So CSS is not fun. Was the least fun of all of it. But sticking to HTML there, I really try to to the spec, and that of course also gives you room to leave out certain things, like for instance frames. You could say, now this is getting complicated, or what I said about Heisenberg algorithm, you could also just drop it. Then of course it wouldn't work for these edge cases, but that wouldn't impact, let's say, your overall parser, right? If you give it a nice HTML, it would still just produce what you expect from it. And therefore, in this case, you can do it. And I totally did that. But yeah, in general, it makes sense that you have some understanding of the spec beforehand, because that then, of course, also allows you to to make the decision. Can I already leave out some things, already start with some tests and have, early successes here? Or do I need to understand everything, go everything in one sweep? And I think therefore having this high level understanding makes sense, and you only get it by at least having a glimpse on the whole spec beforehand and then deciding how to proceed.
And what about maintenance? I understand the library is HTML compliant to some extent, and obviously they introduce changes. How hard it is for you to accommodate those changes to an existing code base, and all the tests around?
Yeah, actually, since the spec is so good, I wouldn't say it's super difficult, but it's still challenging, because I think that the major problem is identifying first what changed. It is never, let's say, breaking. It can't be breaking, right? But they added something, and that changes something. For instance, specifically around, for instance, the template element, there were a lot of changes around the year. They were never again breaking, but they were always evolving. So things that you beforehand didn't treat at all, right? Certain cases, suddenly they were treated in the spec. And yeah, for me, of course, that it's not that I open this spec every week or every month. So I also just see it when, for instance, there's a bug suddenly reported in AngleSharp. So someone says, well, this thing is behaving. And then, of course, usually some weird code comes up, because these bugs are never in areas where you say it's totally obvious. So some weird code pops up, and I'm like, wait a minute. I remember this area, and this should, but this is the expected. Oh, wait. So I go back to the spec, and then I realize, they now added something, and now this case that exactly in this code is happening is covered. So now I need to get active. So I look around the algorithm, and then again, it helps that I have my functions always, or the methods in the parser class, which is huge and too long potentially, but anyway, that they are always mapped to these sections in the spec. And so I can then just compare, and I immediately, or more or less immediately, see where they are diverting, and then of course make the change. So I wouldn't say it's super difficult, because the spec is quite good, but it's still of course challenging. It's time consuming mostly, because you need to do this detective work essentially, and go to the basics of it, and then of course apply the change. Yeah, add a unit test of course for the bug, and then fix it.
Cool, sounds good. Do you think your unit tests could be used by some other projects? I mean, there are many HTML parsers out there. Is it possible, technically doable?
So sure. I actually also used, so AngleSharp now has, I don't know, I haven't looked up the last number, but around 4,000 unit tests. And most of these tests, well, let's say at least 1,500, maybe 2,000 of them, I just copied over already from existing test suites. And they were not only HTML test suites, but they could also deal with other areas that have been implemented in AngleSharp. One example there is, for instance, we have our own URL class in there. Now you could say, well, .NET already brings URI, and honestly, I would have loved to use that. However, it's worthless, because it doesn't follow the spec. It doesn't work just for the pages. I mean, it will work under some very nice circumstances, but already if you provide something that .NET doesn't understand, I think emojis is, for instance, already one example, it will just throw an exception. There's even no other way that you say, well, just ignore it. It formulated this thing was actually invalid, but just keep on doing. You can't do that. And that's already, I mean, the web will never say this. You will never go to a website and the web page will crash in front of you and say, but by the way, there was a URL in there I didn't understand. It will never happen. It should never happen. Of course, it could still be an invalid URL, so that's all fine. but the web will never crash. So it will always proceed, and then maybe it will go to some fallback value. And that's, for instance, what our URL parser does. And it has a full test suite for URLs in there, and can cope with everything except IP version 6. We still detect that, but there we just say these rules are getting bonkers there with what you can do with the colons, etc. We just trust that this host name is valid IP version 6. We just accept this as host. And once we see another, we go to the path mode. So there we just say, we are out of here. But so for the host, we really we trust you. But otherwise, it's fully implemented for paths and all these things, right? What you can do. And yeah, again, it was necessary. And this, by the way, is its own spec. This is not, of course, in the HTML spec. It has its own spec. And what we did there, because it was not so nice as the HTML spec, is we made a snapshot of the spec that we can always diff it, right? And we actually, I think we placed it also in our GitHub repository somewhere. But anyway, so that we can always compare it. And we also have it as our own version of the spec out there that we can always update it and see when some things change. But there weren't so many or no crucial changes in recent times to your spec, fortunately.
Cool. So we have this project. Where do you use it? Or where do you know people use it?
It's actually used in a lot of things. So, I mean, sometimes I'm surprised, but Blazor, for instance, was using, in the beginning at least, and I think it's still part of the Blazor source code, was using AngleSharp. They were, I think, then freezing it or using a snapshot of it. But Blazor, when it started for the razor syntax, etc., for identifying these things, they were using AngleSharp. But then it's used, of course, mostly when, let me take another example. Sometimes it's used underneath that you don't even see it's being used. Well, one example would be there is an OIDC middleware for ASP.NET Core, and this one uses AngleSharp, for instance. So when it communicates and it gets back some HTML and needs to identify the form and some values in there, it uses AngleSharp to parse this. And I think it makes sense for any HTML parsing to use it, because again, I mean, you could use something like HTML Agility Pack 2, and that might just work. But if they throw something at you where only a valid HTML5 parser then gets along, then this is the part where you would need to switch to AngleSharp. At the moment, at least, there's no other project that I'm aware of that implements a fully compliant HTML5 parser in .NET. There was, I think, what was it called? The new parser or something. I forgot the name, but yeah. So it was a port, I think, from a Java project or so. Anyway, so they also implemented it, but unfortunately the maintainer stepped back. I think it was already 7 or 8 years ago, and then recommended also AngleSharp. It's always good to have multiple choices out there. I'm a strong believer in multiple choices. So there is not one size fits all. It always depends on the problem. And so AngleSharp does a lot of things. And if you're not interested in many things it does, so maybe there's a more lightweight alternative to what your problem is, right? So, but anyway, at the moment, I'm only aware of AngleSharp as an HTML5 compliant one, right? Yeah.
Excellent. Pretty impressive project. I know from the last 2 times we met at conferences that you're a big supporter of micro frontends.
That's right.
And one of your open source projects is also pegging that niche. Would you like to dive into that? Because I find this super fascinating.
Yeah, totally. So let me just start with, I mean, I was never a full front-end guy. I always considered myself more like a back-end guy. I think you've heard that already from the background where I started. And but a couple of years ago, I was at an IoT project, and so Internet of Things, actually a smart home platform was developed in this project. And for some reason, I took over the front-end architecture. I don't know how I came to that. Suddenly, it was in my hands. I wasn't too unhappy about it, to say it like this. I wasn't doing React at the time. So, I mean, I heard about it, but I never used it in any real project. And I was fully React-based. And I thought, well, let's see what the hype is all about. So I was up for the challenge, so to speak. And what made this also very interesting is that the smart home system was quite modular, right? So they were already of course, they had, as it's usually in these architectures, they have a so-called smart home controller, which is a little box that gives you all the connectivity at home. But then, of course, you just could buy whatever you want, like a window door sensor or, a smart plug or all these things. And then if you had a new kind of device, then out of the box, when you connected it to the controller, a device driver was loaded and provisioned for you, and you had this thing, right? And so quite modular. The device driver could be developed by some other team that is potentially now in charge of this device, right? So the team that develops the smart plug can say, we also develop the driver for it. So the hardware perspective, totally modular. However, now we're entering the front-end space, and this is a monolith, right? So one team is doing the UI here. This team also needs to know how all the devices work. And now there's a smart plug. So you need to implement UI for a smart plug, which is maybe not so difficult for a smart plug, because maybe all you can do with it is turn off, turn on, right? So yeah, you have one button in there. But let's take something more complicated. Philips Hue or ambient lighting, where you say, okay, now you have colors and everything. How do you communicate with the API now of this thing? You would need to know the driver behind it. Do you know all the possibilities? What if there's an update? Now the hardware can do more, or there's a new version of it. You need to take care of. Wouldn't it be better if the team that does the driver, that knows what the API can do with it, does also at least part of the front end, right? That would be much better. So what we ended up with was a modular system where the basics of the UI were all already, let's say, dictated or pre-given, like, a standard set of UI components. How does a button look? What's the general feeling of the UI? How do you get authenticated? All these things just determined for you. It's layout determined for you. But then everything that goes into device world and also into specifics of services, like scenarios that you could create, or rules that you can configure, and all these things, these are left now to individual teams. Could be still the one front-end team that does now also these services, or partially. But in theory, you could say, well, I own this device, I write the driver for it, I also provide you the UI that can do everything with it. And this, I think, was in 2016, and the project was quite cool. That went quite well with the modularization. I thought, well, actually, this could be applied to other things as well. Let's see when it comes up next. And for some reason, a lucky reason or not, in 2017, I was on another project doing a kind of a customer portal solution, right? And there, at first it read like your standard monolith, right? So we want to have a customer portal, and well, it should have all these functionality. And you're like, okay, yeah. And then they suddenly said, well, but by the way, depending on what kind of customer it is, there are a bit different business units we have, so must have different functionality. And by the way, most of this functionality will not be provided by your team. We already have existing applications, and they are in existing teams. They are in these business units. And there will be more teams in the future. And I'm like, okay, maybe not your standard
great fun, yeah.
now. Yes. So, and then I thought, wait a minute, we had this smart home project, and that already made it modular. Maybe let's go a step further. So I don't want to say I took the same architecture, but at least some of the ideas I refined it. Of course, some things got better also in my mind over time, like it happens, right? So you think, this was not so good, this could have been improved, let's just do it a little bit differently. And so this iteration was also quite good. We had quite a large development team, so our core team was around 20-25 people, and then all the business teams which were 6 to 7 teams in the beginning with. So we're talking then in total 60 to 70 developers, but the overall feedback was really good. So also the existing applications could be embedded quite nicely, and there everything worked. And so I thought, if I do something, if I ever change company again, what I want to do is bring this concept now into a framework. And this is where the idea of the Pyra framework was born. And since then, I've written a book about microfinance. As you know, also Christian, I'm going to one or the other conference talking now these days more or less exclusively about microfinance or topics that go in that area. And I'm a big fan of having this modularization. It doesn't mean that I'm saying it's the only way to do things. That's actually the contrary. I'm saying there is a space where if you have these problems, this could be a potential solution. But I'm always also saying, if you're happy with your monolith, and then stay with your monolith. I mean, keep simple things simple. I mean, complexity is toxic usually, because they will always cause more complexity. So let's not bring it in there. So what I'm dealing with there, and why I find that space really interesting, is because it brings together a lot of the complexity we have in front end, tries of course to simplify, but also tries then in the end to accelerate and to empower teams again. And this is what I like, the cycle that, I mean, there is this complex thing, and the web is complex. We know it, right? We were talking about specs and all the mess for the whole time here. But then on the other side, there's of course a level of simplicity above it. And this is exactly the point where I always like to be. But finding this balance that you say, you can bring the complex things somewhere to a level where only a few people have to deal with it, and to that the more easy things, they are there. And this is what then makes teams efficient and powerful. This is where I like to go. But yeah, because Microphonics is still breathing thin air here, so it's still quite early. The adoption increases year after year, and make always a survey each year. And it still shows that this is still a growing space. And I'm not surprised by this. It's a problem that doesn't, of course, appear in every project. It shouldn't appear in every project. So, but on the other hand, of course, it's still people are cautious to go there. It's also good, but yeah. So it's still early days in that space, and I like to be in that space.
I love this scenario you described. Right, I'm seeing so many projects where the architecture team is trying too hard, right? And then I think Joel Spolsky once called this architect astronauts. But on the other hand, in scenarios like you described, having a sound architecture is kind of the only option to make the whole project viable and doable, right? So that's actually pretty amazing, especially when you're in the position that you already had that concept in mind, and that you could directly map it. So when we are using your open source project, right? So what are the prerequisites, or how should we get started with that?
Yeah. So just a little bit of background. So Pyra itself is a generalization of the customer portal I've described. And of course, with that came some assumptions. Some of these I wouldn't do again. Let's phrase it like this. So in the current state, what you get there is you start with something that is a so-called app shell. So what I described before, and this is your application as a whole. It could be also just your today's monolith, right? So you wouldn't care about it. We just call it app shell. It doesn't mean it should be a full shell, so it's really empty. There could be something in there, but usually you try to keep it minimal, right? And this is actually where the framework goes. It comes with a so-called orchestrator. So this is a thing that will, in the end, load these micro frontends and always then be able to render these components. Underneath, it uses React. So this is already one of the assumptions that I was talking about. In version 2, we will actually correct this. There will be just this orchestrator, and you could use it in any framework. Could be just your HTML page also. You wouldn't care. You wouldn't need a bundler and all these things. Right now, you need all these web technologies underneath to make it work, right? You can choose your bundler. It's actually agnostic. Could be Webpack. Could be ESBuild, could be Vite if you like this, if that says something to you, right? So it could be anything, yeah. So once you have this, you create your app shell. It will actually give you two artifacts in the end: something you upload to your web server, and something that you can distribute in a tarball. So just put it on npm, for instance, or in your private npm registry. And this second thing that you get for now developing microfrontends, because the basic idea behind this is a little bit similar to if you write an extension, for instance, for VS Code, right? You have on the one hand, you have VS Code. This is like your app shell, and it runs already. It runs on your computer. But now what you want to do is you want to create a plugin. You could now just write code and hope that it works. But usually you want to debug this, right? So when you start it, you start a special version of VS Code in this case. So what we do is an emulator there that you publish as a tarball. You start a special version of your app shell that you developed beforehand, right? So you see already your microphone and working in the real thing, essentially. You can also consider it, that's why we call it emulator, like an iOS or Android emulator. And that would just work. So this works now with any framework. The basis is React, as said, in the app shell, but for your actual microfrontends, you can use components in anything, right? Could be React-based components. That makes most sense because React is already part of the app shell, so there's no extra cost. but could also be you use Angular, works. You use, I don't know, Vue, and this is also one of the things, use Blazor, right? And this is the only micro-frontend framework that works with Blazor. It does their bridging to all the C#, but it only works with Blazor WebAssembly at the moment. However, announcement, not full announcement, real announcement will come later when we open source this. But what we have working already since a couple of months, we did a project together with one of our customers. We have a full version of Pyra that exclusively was built within C# using Blazor. And you get your app shell already defined in Blazor, and you write them .NET libraries. We only change the SDK to a custom one, and then you can run your libraries, your RCLs that you had beforehand as microfrontends. And that actually is a lot of, it's really cool. Because also it works fully server-side there, and that means you don't even get extra cost. What we will potentially do, and then we will fully open source it, we will try to make it work with the .NET 8, with the Blazor United model.
That's what I wanted to ask,
yeah.
right? So
Yes.
so with the new well, I don't like the term static server side rendering. I mean, it's either static or rendering,
Yes.
but anyway, but yeah. So how that applies to what you've built so far, right?
Yeah, I think just in the static mode, it would also just work, because right now what you can see, I mean, it works as Blazor server, which of course already does the static rendering, right? Now the tricky part will be that there is then this hydration also, or potential hydration, at least in the auto mode, etc., going on with the WebAssembly. But yeah, for that we also, it seems doable so far, and let's see, we will start investigating this more in December, and then we will open source this, or maybe even beforehand. Because right now it already works really cool. The coolest thing about it, as compared to the other kind of microfrontends that live, for instance, in the browser, also with WebAssembly, is that in this area you don't share any dependencies, .NET dependencies. You can even get dependencies in multiple versions in there, because we open for each microfrontend an own context, so an assembly load context, and that essentially shields it. And so you can have version 1 of some library and version 2 of another library. And so these will just happily coexist next to each other, and they will be loaded together with their microfrontends, and everything is fine. Also, it has a little bit of a different model there with what we call Pyra Blazor server at the moment. You distribute a microfrontends as a NuGet package. So everything just works from Visual Studio out of the box, which is quite cool. So you could have a NuGet feed. Could also, of course, just be your directory in a shared space somewhere, right? And you draw the microfrontends from there, at least the server draws it, and then if you update something on the fly, it will pick it up. And this is really magic. You have your Blazor server running, and you see this website in 3 things, and then suddenly just one component changes in all of them because someone just published a microphone. You could, of course, disable that, and for production, we always recommend this, because you don't want things to just change without you know, having full control over it, or at least saying, well, the customer needs explicitly to hit F5. You don't want, change a web page while it's running without the user doing something. But nevertheless, it's quite cool for demos, and this will be quite kick-ass. So Pyra Blazor server microphone solution fully done in C# and Blazor, and with full dependency isolation. So quite cool thing.
Yeah. That sounds fantastic. I mean, in a way, Blazor, especially with the .NET 8 models, is kind of a micro front-endy thing because it's so much component based. Yeah. But especially the use case you mentioned, right, with different teams working on things, maybe without even talking to each other, that kind of makes it really convenient, especially in those larger enterprise settings. You definitely have to come back once this has been open sourced, and then we have to talk about that in depth. I would love to see that. Yeah. All right. I mean, the third the third big open source project you are maintaining or co-maintaining is maybe the one most people have heard of to some extent, right? Because they know half of the name at least. That's Electron.net. So just briefly, would you let us in on what that project is doing?
Yeah. So as you already mentioned, it was originally founded by 2 other German-based developers. I mean, Robert Müßig is now living in Switzerland, but still.
Yeah.
in the German-speaking region, and Gregor Biswanger. And what they found is that it would be really cool, same idea, so it all goes back, if you could write an application logic using C#, but having all the presentation layouting done with HTML and CSS. Because as I did in the plane, they also thought, well, that's the one true thing that goes across multiple operating systems. And the thing that they did better, and that's why they had more success in ending up with a presentation framework, is that they were then just basing this on an existing solution. So they've chosen Electron, which is already, well, you could think of it like Chrome without, dictating that a browser needs to have a URL bar and all these things in there, right? But it's essentially Chrome. It also has a little bit of other details in there. For instance, it runs the real V8 engine with Node.js instead of just V8 with, everything browser context based. It still has a browser context also in there, which makes it sometimes weird in some scenarios, but usually you have the full Node.js API available. And that makes sense because you want to develop usually in the Electron model against, for instance, the file system or the standard system. Even though I would argue these days, not when Electron was created, but these days, you can do all these things also with the browser, right? It even gives you access to the file system, sometimes behind permissions and so on. But this could be just short-circuited or something like that for Electron. But anyway, so you could think of it like your Chrome, where you define what is the web page being loaded, and what Electron does not
essentially like PhoneGap or PhoneGap/Cordova or Titanium.
Exactly, just for the desktop, not packaged now for a mobile phone, but essentially right? And where the mobile phone already had then a working browser and just, did need to trick the web view. This thing, of course, gives you the web view, which has the downside that you load another full version of Google Chrome, essentially. And that's one of the criticisms that Electron usually gets. It uses a lot of memory. And of course, the minimum installation is, what is it now, 80 or 100 megabytes? But, you can't get in a Hello World below that because
storage is cheap.
Yeah,
memory and CPU cycles are not, but
they are not.
Storage
and these things, they tend to hog a lot of it. And of course, this is where a web view or some specialized component comes in handy. But then again, these web views or these specialized components, this is what, for instance, projects like Tauri, I think, are doing. They're just using this from the system given web view. But then again, you're bound to what the system gives you. And luckily these days, it's also Windows something appealing. I think it uses now the one from the latest Edge version, which is essentially Chrome again. But back in the days, it was using the IE one, right? So that the old web view that was using the one from Internet Explorer, and you didn't want to go there. I personally was always a fan of how Internet Explorer did the rendering, but let's keep it straight. You don't want to have the JavaScript execution from Internet Explorer, and also in CSS nowadays, it would be too outdated that you do something viable with it. Nevertheless, so it comes with of course, this drawback that it hogs a lot of memory, but then you get the assurance that you get the same rendering in Linux, in macOS, and in Windows. And that's, for instance, what the success of VS Code is, because they're just using this thing. So they're just having a web app, and then it just looks and works the same across platforms, and it even works on the web. And one can now criticize it, but on the other hand, it gives you a really flexible model and all this. So there is, of course, some space where you say, I don't want this, but then there are many reasons to also say this could be the right thing for my next UI project. And so what Gregor and Robert did is they created a wrapper around it, Electron.net, which then allows it just right now, a .NET component could be now Blazor these days, but classically it was an ASP.NET core or ASP.NET web page. And you were defining your application logic like you do usually via API calls, and then it spits out some presentation, and this is then what's rendered in your UI application, right? So it runs a little server inside, communicates there, bridges essentially the C#, the JavaScript code by just going into the C# world on the server there. And what we will do there is, right now the project is a little bit in maintenance mode, but we will do a few things soon. The most major update, what we will do is right now, it has a little bit of a weird release model, and it is always bound to a certain version of Electron, which is then, of course, bound to a newer version of Chrome and comes also with other benefits.
So you could update every 6 weeks, actually.
Yes, in theory, yes. And of course, if you don't do this, which is the usual case, people are then stuck at some version. But then the other downside of this model is, of course, there is maybe a bug fix or something, and due to our time constraints, we only do it on the most recent version. If you're now stuck on an older version, even though the fix could be, in the C# code, so nothing to do with the used version of Electron and all that, we usually don't do it, which is, of course, in my opinion, it sucks. It's an unfortunate situation. So in order to, let's say, improve this, there must be two parts. So one part is now all the .NET wrapper that you get, and then the other part is now the real Electron bridge underneath. And so you could have two different versions, right? So one is the .NET wrapper that goes, and we just have this released, and then you just pick the Electron part for whatever matching version of Electron you want. So this will be quite cool, and it may also come with certain improvements. For instance, for debugging, at the moment you need to attach your debugger. People seem to to get along with that, that they just start this thing from the command line and then they need to manually attach it in Visual Studio. Personally, I like the approach that I mentioned with the Pyra Blazor server much better, where in your microphone you just change the SDK, you still press F5, and then it just starts, and you can still make your breakpoints and everything as you know it, right? It should just work. And that's a little bit where we are aiming to get, and hope that we will soon have enough time to realize all these plans. So there's enough planned for Electron.NET to make it even better.
So lots of stuff coming, lots of New Year's resolutions you have there. Looking forward to what's coming out. But yeah, I'm super excited about especially the Blazor 8 version of Pyra. Excellent. Adam, anything else you'd like to touch upon?
I'm just looking forward to the day when I can deprecate the .NET browser that I'm using in one project, because when it runs for like 2 weeks, it hogs 60 gigabytes of memory, and they claim Chrome is memory consuming.
Well, will it get better if you have something based on Chrome? I ask.
No idea.
we will find out. We will find out soon. All right, gentlemen, that has been fantastic. I would say time for picks. Adam, would you do the honor to be the first to go today?
Sure thing. My pick, as usual, I try to be something software-ish or hardware-ish. So for this week, I have something that is called Limbo Emulator. And Limbo Emulator is basically QEMU for Android. So I was pretty surprised this week when I learned that you can virtualize Windows on your Android device, and it works. It's too slow still to use it like on a daily basis, but I'm looking forward to those fantastic days, hopefully in like a couple of years, when I'll be able to virtualize Windows on my Android phone and do some fancy magic. So Limbo Emulator, obviously it can run other stuff as well, some small Linux editions, some full-blown Ubuntu or whatever else you need. I tested it out with Windows 10. It did work. Looking forward to a decent performance one day. And then obviously I will go deeper and try virtualizing Android inside Limbo inside Android, because why not?
Why not? Because you can.
Exactly. Back to you.
Excellent. All right. I already had planned a technical pick today, but then I switched for streaming because I somehow got hooked to The Lincoln Lawyer. Which I believe runs on Netflix everywhere. So it's based on the book The Lincoln Lawyer by Mike Connelly. It was already made into a movie. I don't know, 12 years ago or something. But now it's a series on Netflix. Well, or a TV series. Let me say it in a more generic fashion. Actually, there's already a second season out now. Maybe that's how I noticed, which is great. So I can, just do binge watching, not just one season, but two. And there will be a third season as well. And it's a Lincoln Lawyer because it's a lawyer that drives around in a Lincoln and does his business from there. And yeah, so I think they're using the book in the first season and then maybe expanding the universe there. It's just good fun and kept me entertained. for the last few weeks. So that's my pick for this week. Florian, what do you have
Awesome.
first?
Great picks so far. We'll need to look into both of them. Series always make me addicted, so yeah. For the sake of Electron.net and the mentioned projects, maybe I should stay away from those.
Actually, there's a third season of Lupin as well. So don't get even started. Some great stuff coming at the moment.
Okay, awesome. So my pick would be a book from Michio Kaku. It's not just recently released, but it's the one that I'm currently reading. So I'm always like 2-3 years behind on my books. My wife always gives me some great books for my birthday and so on. And I don't know. I hardly manage to get over 1 or 2 books per year, but this is the one I'm currently at. I think it's really great. So Michio Kaku is a physics professor at New York State University and wrote also some awesome books in the past, like Physics of the Future. Also highly recommended. So this one that I'm now putting on the list here is called Quantum Supremacy, and deals essentially with quantum computers and how they could be used to, well, in his own words, unlock the mysteries of science. And I would also add also unlock the mysteries of some very security sensitive keys, but that's for another story, right? And
that sounds like a horror story, actually.
It's a horror story, yeah. Fortunately, we are not there yet, but once they reach that milestone, I know that we need to also get potentially quantum chips inside all computers, because the only then countermeasurement is to also make cryptography on another level, right? So when classic cryptography can be broken by quantum cryptography, maybe the countermeasurement is just to put everything into quantum cryptography somehow. But anyway, it's a great book. Can only recommend it. And this is my pick.
Excellent. Great pick. Thank you very much. Thank you very much for coming, Florian. Has been great pleasure. Fantastic episode, and you definitely need to come back. Would love to have you again anytime. Thanks all for tuning in this week, and hope to see and hear you again next week here on Adventures in .NET.